Welcome to my YouTube channel. I studied today for welded joint subjected to the bending moment. First apply the load on the cantilever beam which is jointed by the all sides of the welded joints. This is fillet weld joints, which is two portions of the verticals and two are the horizontal fillet joints. Therefore it makes like a bracket fillet joints. And the cantilever beam is also joined by this bracket frames. And apply the load at the cantilever from the first plate to the cantilever. Load is eccentricity is given 200 millimeter and the load is applied 50 kilonewton is 200 millimeter. Therefore, from question we got applied load 50 kilonewton at a distance of 200 millimeter, and the bracket dimensions are D equal to 200 mm and B equal to 100 mm. For calculating the thickness of throat, T in mm, and again leg dimension, H1. For this calculation, first we found out the primary shear stress, tau 1. Next find out the bending stress, sigma b, and combination of the both primary stress and bending stress, finding out the maximum shear stress, tau equal to, we know that the maximum shear stress theory, bending stress divide 2 whole square plus primary shear stress whole square, which value is in Newton per millimeter square or megapascal. In question also given allowable shear stress, tau allowable equal to 100 Newton per millimeter square. Therefore, for finding the primary shear stress tau 1 equal to, first find out the total area of the fillet weld. Now we first here showing the fillet weld area, which is rectangular section, then T into D is the first rectangular section and B into T is the second rectangular section. This is the rectangular cross sectional area. Here two rectangular sections and two horizontal rectangular sections, two verticals, then therefore multiplying by 2. Now calculated, dt is equal to 200 into T plus 100 into T. Therefore 2 into 300 T, 600 T. This is the total fillet area. Now finding primary shear stress, tau 1 equal to P by A, which is the total area. Now the P is the 50 kilonewton, divide area equal to 600 T. Therefore millimeter square. Therefore we got tau 1 83.33 millimeter square. उसके बाद now we calculate the bending stresses. This is applied the load 50 kilonewton, and first we finding out the primary shear stresses 83.33, and bending stresses equal to sigma b equal to, we know that mb into I divide Ixx. For calculating the moment of inertia about Ixx, which is the Ixx, therefore there are two sections. This is horizontal fillet welds are in parallel axis theorem applied here for the finding the moment of inertia, and for vertical section this is only for the apply the moment of inertia passing through the center of gravity. And I have saying earlier question where the thickness of the T is very small, therefore here Ig equal to neglected and the second portion is only taken here. Now the formula is Ixx for section 1-1, this is the vertical sections of the fillet weld, Ixx 1 equal to T into B cube divide 12 into 2. There are two vertical sections. In my previous lecture, we had calculated the section of the horizontal fillet weld, which is dimension through d from y equal to, here d by 2 is the, which is the y part. Now the y axis denoted the from the far from the x axis dimension. Therefore Ixx2 equal to T into B square Ixx2 equal to, this is the area B into T, here T and here B, and far distance is d by 2 ka whole square. Therefore when double horizontal welds are here, therefore last calculation is BD square by 2. Then Ixx plus 2 divided by 12, therefore this value is 6. Now the Ixx we find TB cube divide 6, and which is written here, and Ixx2 is equal to T into BD square by 2, which is written here. Therefore we taken common T, where B cube divide 6 plus D square by 2, where B is the 100 millimeter and D is the 200 millimeter. Summation of the Ixx equal to some value, my mistake we have written here is the B, where this value is here D and here D cube, and multiplying by B, this is the summation of the total Ixx. Now the value is here Ixx equal to T into D cube by 6 plus BD square by 2. In equation moment of inertia of summation of the moment of inertia Ixx, which is measured in millimeter per power 4, here putting the value of the distance, depth of the D 200 millimeter and width D 100 millimeter and depth D, and applying all the values, and we got 3.333 into 10 to the power 6 into T millimeter per power 4. Applying the couple, MB equal to 50 kilonewton into 200, P into E equal to 1 into 10 to the power 7 Newton per millimeter. Bending stress sigma B, formula is MB into Y divide Ixx. Therefore 1 into 10 to the power 7 into y equal to half of the depth d by 2 equal to 100 millimeter into 3.333 into 10 to the power 6 into t, and after that sigma b bending stress is 300 divided t Newton per millimeter square. Now we find out the maximum shear stress tau equal to, we put the value of the bending stress divide 2 whole square plus primary shear stress tau square, where the value is 300 divide t, 300 divide 2t whole square plus 83.33 by t ka whole square. Therefore the value is, this is the maximum shear stress 171.6 divide t is the throat thickness Newton per millimeter square. Now we put the tau yellow bulb equal to 171.6 divide t, implied t equal to 171.6 divide tau yellow bulb equal to 171.6 divide 100, which is given in question 100 Newton per millimeter square. Now ultimately we got the 7.16 millimeter, which is the throat thickness of the weld. Now in last, the leg length of the weld equal to t divide 0.0707, then we put the value of t 1.716 divide 0.707 equal to 427, and we have taken for the safety consideration, this is the maximum value, which is round off is 3 millimeter. Then weld leg length is 3 millimeter, which is h value, and the throat thickness is t value. Thank you.